And of course, as in any other programming language, we are able to do operations such as addition, subtraction, multiplication, division, and the modulo operator. Okay, so those are the basics ones. So this is very important because any programming language has to be able to do this. Now let's take a quick look real fast here. How do we do this in Kotlin? Well, back to our main, going to create a variable, val a is equal to 23, and val b is 12. So I can just print, of course, say a plus b, the result, this. Let's see what's going to happen. Should we have 35? And there you have it, 35. So very simple. Let's see if we want to subtract. We'll just go, say, dash minus there, and we should get a number. 11, that's very good, very simple really. And let's see, we want to multiply. Multiplication is going to be asterisk. So there we go, run, there it is. If we want to divide, /, and we get 1. It seems like that we have a problem because if we divide 23 by 12, it's not necessarily 1. What's going on here? Well, the reason being is because when we divide integers, we don't get the right result. So we have to change these to double to get the correct result, or one of them at least, but let's change both of them. Look what's going to happen. Talk about precision again. You can see if we do that, then we get the correct number, which is 1.916 and so forth. So this goes back to that idea of types, that how important they are. It's not wrong when we divide 23 by 12 and get 1. I mean, in the computer way of thinking, quote unquote, that's not wrong. But the problem is that it's wrong mathematically because the way things are done in memory when we're dealing with integers, right? So if we're dividing two numbers that are integers and the division, the quotient is actually a double, well, the result is always going to be an integer. That's why we get the 1. Because if we ignore all of this, decimal numbers, we will see that indeed all it's been read is 1 because this is an integer. The rest is gibberish when the types are integer. So always keep in mind, if you are dividing integers, if the result is actually a floating point type, you will get a result that is wrong. See, let's do this again. That's a very good, interesting lesson when it comes to types in Kotlin. Let's run again. It says 1 because, again, it's ignoring anything else. It's saying, okay, well, it's going to be 1 because that is the integer. It goes and finds that 1 dot whatever else it needs to happen, whatever decimal places we have, it's going to ignore all of that because this is an integer. So it goes and gets just 1 because these are integers. But if we just change 1 to a double by putting .0, the whole thing changes because now we should get a precision. So we don't have to put for both doubles, just one double, one integer. The result is going to be a double, which contains indeed precision that we need. In turn, that's the correct result. Programming. So things to always keep in mind. Very, very important when it comes to division. All right, so we have that. Now let's look at the modulo operator. Okay, what does that mean? Well, it's the remainder operator. So if I say, for instance, let's just change this, say 10, and this is going to be 2. If I change the operator here to %sign, what's going to happen? Let's run this. Right, it says 0. What's happening? Well, it's very simple. It's the remainder. So when we do this operation, we are looking for the remainder, meaning if we divide 10 by 2, what is the remainder? Well, the remainder is going to be 0 because 10 divided by 2 is indeed 5, and the remainder is 0. However, if I change this to 3, right, what's going to happen? Right, we have 1. Remainder is indeed 1 because 10 divided by 3 is 3. 3 times 3 is 9, and remainder is 1 to get to 10. So you would use a remainder in certain cases where, for instance, you want to get multiples of 3 from a list, or multiples of 2, or multiples of 10, or whatever it is. You can actually use remainder and do a little bit of calculations to figure out certain things. So there's a lot of use for remainder. Okay, very good. So we've learned about the basic operations. So addition, subtraction, multiplication, division, and the modulo operator.